Hello students, myself Antara Kaushal, Assistant Professor of EC Department of Guru Nanak Institute of Technology, and this is my lecture series on RF and Microwave Engineering, and the code is EC701, which is for the undergraduate student for BTech course for 7th semester under Electronics and Communication Department. Welcome to this first lecture of the course of RF Microwave Engineering. And in this lecture, we give a brief introduction to microwave engineering. That RF means radio frequency, and this radio frequency engineering, which involving the application of transmission line, waveguides, antenna, and electromagnetic field principle to the design and application of devices that produce or utilize signals within the radio band. And the frequency range is of about 20 kilohertz up to from 20 kilohertz to 300 gigahertz. Now, this microwave engineering basically involves signals which is between 1 gigahertz to 30 gigahertz. Now, beyond this 30 gigahertz, the wavelength is in millimeter, and that is why it is called as a millimeter wave range or region. And below 1 gigahertz, we have the ultra high frequency and very high frequency range. So this is more or less the range for which microwave engineering is defined. Now, what happens if suppose this is let it is say that the width and the length of a plate is 30 centimeter by 30 centimeter, and we know that normal if you from normal KVL, that is Kirchhoff's voltage law, at low frequencies or DC, if a signal is applied in the entire copper plate, as long as it is a good conductor, entire copper plate will have the same voltage, but that is not the case here, because here the wavelength of the signal is comparable to the dimension of the plate. That is why each point has a different voltage depending on the wave structure. So the traditional KPL and KCL that we often use for solving network problems at low frequencies or DC are no longer applicable when we come to the microwave range of signal. And this RF, that is radio frequency, that frequencies are designed to operate in the radio frequency spectrum, and this RF and microwave engineering is incorporated into almost everything that transmits or receives a radio wave, which includes but is not limited to mobile phone, radios, Wi-Fi, and walkie-talkies, and digital television, satellite television. And the term microwaves usually refer to electromagnetic waves with wavelengths which ranging from about 1 meter to 1 millimeter, And the microwaves were first introduced in the technical literature in 1932, and after that it continues. Now, the subject name is RF and Microwave Engineering, and that is course name. And the course code is EC701, and the total lectures are 34 for this course. Now, there are some course objectives. That is, first one is distinguish the RF and microwave spectrum, planar transmission lines, and high frequency circuit elements. Second one is to determine the microwave passive components and scattering matrix representation. Third is illustrate the microwave tubes, semiconductors, microwave devices. And fourth one is justify the microwave application and typical microwave test bench. These are the course objective of this course, that is RF and microwave engineering. Now, after the completion of this course, the student will be able to understand the microwave frequency range and their application. Also develop the fundamental understanding of the two-port RF network and matching techniques. These all are the course outcome. Third one is learn the scattering matrix for microwave passive components. Understand the microwave tubes and devices along with their fundamental principles of operation, and also learn the microwave measurement techniques. These are the course outcomes. Now, this is the course content. It is under module 1, there is introduction to RF and microwave spectrum, typical application of RF and microwave. After that, microwave waveguide or microwave waveguides are there. Then planar transmission line, and under that there are different topics. In second module, there is high frequency circuit elements, difference in high frequency and relatively low frequency behavior of lumped circuit components, and waveguide passive components and their S matrix representations, and many other topics. In module 3, there are microwave tubes, semiconductor microwave devices, microwave amplifier design, and there is also module 4, that is under module 4. There are typical measure microwave test bench and measurement of VSWR meter. Now, these are the textbooks and reference books for your reference. Now, in module 1, the first topic was Introduction to RF and Microwave Spectrum. Now, the electromagnetic spectrum that consists of entire range of electromagnetic radiation, and the radiation is the energy that travels and spreads out as it propagates, and the types of electromagnetic radiation that makes the electromagnetic spectrum, which is depicted in this figure. Electromagnetic spectrum is the range of frequencies, it is the spectrum of electromagnetic radiation and their respective wavelengths and photon energies. This is the frequency, wavelength, and photon energy. The electromagnetic spectrum covers electromagnetic waves with frequencies which is ranges from below 1 Hz to above 10 to the power 25 Hz. The electromagnetic spectrum that comprises the span of all electromagnetic radiation and consists of many sub-ranges, commonly referred to as portions, such as visible light or ultraviolet radiation. The various portions bear different names based on differences in the behavior in the emission, transmission, and absorption of the corresponding waves, and also based on their different practical applications. From this figure, we can see that the frequency range is divided into separate bands, and the electromagnetic waves within each frequency band are called by different names, beginning at low frequency, that means long wavelength, because relation is the lambda equal to c by f, that is wavelength equal to c by frequency. That's why if the frequency is low, then the wavelength will be long. Now that is that beginning with at the low frequency and long wavelength, and end of the spectrum, these are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays at the high frequency with short wavelength at the end. Now, the electromagnetic waves in each of these bands have different characteristics, such as how they are produced, how they interact with matter, and their practical application. The types of electromagnetic radiations are broadly classified into the following classes or regions or bands or types. Okay, now that is first one is gamma radiation, X-ray radiation, ultraviolet radiation, visible light, after that infrared radiation, microwave radiation, and radio waves. Radio waves. And this classification goes in the increasing order of the wavelength, which is characteristics of the type of radiation. Nearly all these frequencies and wavelengths of electromagnetic radiations can be used for spectroscopy. And the radio waves and microwaves are form of electromagnetic radiation which with operating frequencies ranging from 30 to 300 megahertz and 300 megahertz to 300 gigahertz respectively. Now, different types of microwave application and technologies will use certain frequency band to avoid frequency interference, and these frequencies are grouped into several smaller bands, which is shown in this figure, and already I have discussed uh, previous. Okay. Now, the most commonly used frequency spectrum classification today is created by the Institute of Electrical and Electronics Engineers, that is IEEE. These are the some types of electromagnetic radiation. This is the wavelength and this is the radio wave. It is used to broadcast radio and television. And for the microwave, that is used in cooking, radar, telephone, and other signals. For infrared, that transmits heat from sun, fires, radiators, and invisible light that makes things able to be seen. For ultraviolet, that absorb the skin used in fluorescent tubes, and in X-rays that used to view inside of the bodies and objects, and for gamma rays, and this gamma rays is used for in medicine for killing cancer cells. These are the types of electromagnetic radiation. Here in this table, the most commonly used frequency spectrum classification is shown. That is, if that is the electromagnetic wave spectrum under the frequency band, and that is the wavelength. Now under radio waves, there is very high frequency, that is 30 to 300 megahertz. The wavelength is 10 to 1 millimeter. And under microwave, there are different frequency bands like ultra high frequency band, that is from 300 megahertz to 3000 megahertz. The wavelength is 10 100 to 10 centimeter. And there are different bands like P band, L band, S band. Super high frequency, that is SHF, that is 3 to 30 gigahertz, and the wavelength is 10 to 1 centimeter. And also there are another bands like S band, C band, X band, KU band, K band, KA band, and all these bands are used for different application. And under the millimeter waves, there is extremely high frequency, that is EHF, that is the frequency range is 30 to 300 gigahertz, and the wavelength is 10 to 1 millimeter. Under these millimeter waves, there are different types. Also, there are another types of frequency band like Ka band, which is from 26.5 to 40 gigahertz, V band, W band, and millimeter band, that is 110 to 300 gigahertz, and the wavelength is 2.73 to 1 millimeter. These are the different IEEE frequency spectrum. Now, there are some advantage and disadvantage of this microwaves. What are the advantage? That is that advantage is there are different many advantages, like this microwave supports larger bandwidth and hence more information is transmitted. For this reason, microwaves are used for point-to-point communication. More antenna gain is possible for this microwave. Higher data rates are transmitted as the bandwidth is more. Antenna size gets reduced. The frequencies are higher. Low power consumption as the signals are of higher frequencies. Effect of fading gets reduced by using line of sight propagation provides effective reflection area in the radar system. Satellites and terrestrial communications with high capacities are possible for these microwaves. Low-cost miniature microwave components can be developed, and the effective spectrum usage with wide variety of application in all available frequency ranges of operation. These all are the advantages of microwave. Now, also there are some disadvantage of microwave. That is, cost of equipment or installation cost is high. They are they occupy more space. Electromagnetic interference may be occur, and various type of dielectric properties with temperature may occur, and inherent inefficiency of electric power is there. That's why these are the disadvantage of microwaves. But the advantages are greater than the disadvantage. That's why microwaves are widely used for different applications. Now, that's all for today. This was the introduction class where what is microwave, what is RF, radio frequency, which has been discussed, and after that, what are the electromagnetic spectrum, and what are the different types of electromagnetic radiation are there. After that, this is the IEEE frequency band which I have discussed, and the last, what are the advantages and disadvantages of microwaves. These are the advantage and disadvantage. And that's all for today. In next class, we will discuss about another topics on this microwave and RF. And if there is any query, you can mail me, which is which has been given in first slide. Okay, thank you.